Hello friends, today we are going to discuss colligative properties. So the definition of colligative properties is the properties which depend on the number of solute particles but not upon their nature are called colligative properties. There are total four colligative properties: relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure. Let's see the first colligative property out of them, that is the relative lowering of vapor pressure. The addition of non-volatile solute to a volatile solvent decreases the escaping tendency of the solvent molecules from the surface of solutions as same of the surface area is occupied by non-volatile solute particles according to Raoult's law. Means the vapor pressure of solution is relatively lower than that of vapor pressure of pure solvent, because solute particles are also on the surface of the solution, and that's why the escaping tendency of the solvent is limited in case of solution. Therefore vapor pressure of solution is always lower than vapor pressure of solvent. And then according to Raoult's law, P1 is equal to x1 P1 naught, and the reduction in vapor pressure of solvent delta P1 is given as delta P1 is equal to P1 naught minus P1. Here your P1 naught is vapor pressure of solvent and P1 is vapor pressure of solution. So instead of P1 we can write x1 P1 naught. So just put x1 P1 naught instead of P1. P1 naught is common here, so in bracket 1 minus x1. Now we know the mole fraction formula: x1 plus x2 is equal to 1. So x2 is 1 minus x1. Equation now reduces to delta P1 is equal to x2 P1 naught. Equation 2 can be written as, so delta P1 upon P1 naught is equal to delta P1 naught minus P1 divided by P1 naught, that is equal to x2. So what they did, they just divide by P1 naught. Okay, if you put this P1 naught over here, it is delta P1 divided by P1 naught, and that is equal to x2, and that is also equal to, because we know the delta P1 value, is P1 naught minus P1. And now we know the mole fraction formula: number of moles of second component divided by total number of moles. So here total number of moles is N1 plus N2, and N2 is number of moles of second component. But since N1 is very greater than N2, because N1 is number of mole of solvent and N2 is number of mole of solute, so N1 is very greater than N2, and therefore we can write this as N2 upon N1. And number of moles formula is mass upon molar mass. For N2 it is W2 by M2, and for N1 it is W1 by M1. M1 is in denominator, so it will go to the numerator. And from that we can rearrange the equation, and this is the final formula, that how we can calculate molar mass of a solute by using relative lowering of vapor pressure. We just rearranged and we got this final formula. Now let's see a few numericals based on this. So question 1: vapor pressure of water at 293 Kelvin is 17.535 mm of Hg. Calculate the vapor pressure of water at 293 Kelvin when 25 gram of glucose is dissolved in 450 gram of water. So here we have to calculate P1. P1 is vapor pressure of solution. P1 naught is already given, W2 is given, W1 is given. W1 is always for solvent, W2 is always for solute. M2 we found the molecular weight of glucose, that is 180, and M1 is molecular weight of water, that is of solvent, it is 18. So we wrote this formula: P1 naught minus P1 divided by P1 naught is equal to W2 M1 divided by W1 M2. Just put the values, and after putting this value we are getting the answer of P1 as 17.44 mm of Hg. So we can calculate pressure of solvent as well as pressure of solution using this formula. Then in next numerical, we are going to see how to calculate molecular weight of solute. The vapor pressure of pure benzene molar mass is given 78 gram per mole at a certain temperature is 640 mm of Hg. A non-volatile solute of mass 2.315 gram is added to 49 gram of benzene. So here your benzene is your solvent and this one is your solute. The vapor pressure of solution is 600 mm of Hg. What is the molar mass of solute? So both the vapor pressures are given. P1 naught is 640, P1 is 600. Then W1 and W2 are given, and we can calculate M2 by using this data. M1 is also given, molecular weight of benzene M1, that is 78. So just put the values over here. Take M2 through to the other side and solve this, and we are getting the answer. M2 is 58.96 gram per mole. In next class we are discussing the remaining colligative properties, that is elevation of boiling point, freezing, depression in freezing point and osmotic pressure. Thanks for watching the video.